Here is the first example in AC circuits. So here we are adding two waveforms. One is V1 of t is sinusoidal waveform, V2 of t is cosinusoidal waveform. Okay, how do we add these two waveforms? The question, he's asking about what is the V final of t equal to V1 of t plus V2 of t. That's what he's asking for. What is that value? Okay, now these two waveforms have, I mean, uh, that their starting point, there is a phase difference between those two waveforms. First thing we can see that's 30 degrees. Okay, now whenever we are adding two waveforms, first thing we need to see is omega is same or not. So in this case we have omega equal to 2 pi f, which is 377. If omega is same, then yes, we can proceed. Okay, so the first important point is make sure omega must be same. If it is not same, we cannot proceed any further, because if it's not same, we cannot add those two waveforms. Okay, even in our real life, it is impossible to have or impossible to add two waveforms with two different omega values. Omega is nothing but, we know, 2 pi of frequency. Okay, so we know that in the United States, not only the United States, the whole world, it is electricity or electrical system is grid connected system. So all the generators, all the motors, all the loads are connected together on a grid. Okay, so when you are bringing a new generator online, that means you're connecting it to the grid, then that frequency here in the United States, our frequency is 60 hertz, right? So our frequency is 60 hertz. So the incoming generator frequency must be 60 hertz, or I think they might accept around 59.99 to 60.01. Okay, that's the range. If it is below this 59.99, above 60.01, that will not be connected. Okay, there is a process to connect a new generator to the existing system. Okay, so when they're connecting it, they make sure that their frequency matches. Without frequency matches, you cannot connect two waveforms. Basically this waveform is coming from one generator, this waveform is coming from another generator, so we are adding those two waveforms. So make sure that omega is same. So here omega is same, so we can proceed. Now the next one is make sure both waveforms are either sine or either cos. Here I have one is sine, another one is cos. So we need to convert either sine into cos or cos into sine. I prefer to work with sine, so I will go ahead and change it to sine. So v2 of t, I'm going to convert that into sine. Okay. So how we're going to convert that into sine? Probably I'm writing this in reverse way, but I prefer this way. Sine 90 plus theta equal to cos theta, and sine 90 minus theta equal to cos theta. Okay, so sine 90 plus theta is cos theta, sine 90 minus theta is also cos theta. Now cos 90 plus theta equal to minus sine theta, and cos 90 minus theta equal to sine theta. Okay, these are the conversions, and we know that sine of negative theta equal to minus sine theta, cos of negative theta equal to cos theta. Okay, so that's how we're going to this is the conversion. Now I'm going to convert v2 of t into sine. So I have v2 of t equal to minus 100. So I'm going to take this whole thing as theta. So can I say, to get it as sine theta, so to get the sine theta, what I'm doing, I'm taking this as theta. So here I have theta. All I need to do is add 90 degrees. So minus 100 cos 377t plus 60 plus 90. Okay, so now I'm sorry, this must be in sine. I converted this into sine. Okay, so now v2 of t is in sine. So I have v2 of t equal to negative 100 sine 377t plus 150 degrees. Now I can do one more thing. I can get rid of this negative term. I don't need to do that, but I wanted to, because here 150 is a big number. I want to have a small number. If I want to have a small number, I should have taken this as minus theta, but that's okay. I'm going to convert. I'm going to change this a negative into positive. So where do you get a negative into positive? Say, for example, minus 100 sine 377t is somewhere here. Now, either if I add 180 degrees, I will reach here. If I subtract 180 degrees, I'll reach here. At that point, the magnitude is going to be the same. Okay, so to keep the same magnitude and get rid of the negative, what I can do, I can subtract 180 or add 180. Here, in this case, I'm going to subtract 180. So I can get rid of this negative by adding or subtracting 180 degrees. 377t plus 150 minus 180. Okay, so v2 of t, I have 100 at an angle of 100 sine 377t minus 30 degrees. Okay, that's v2 of t. What do we have? v1 of t equal to 50 sine 377t plus 30 degrees. Okay, so this is v2, that's v1 of t. v1 of t is minus 60 degrees there. So copy error, I'm going to make that as minus 60 degrees there. Okay, that's good. Now if you look at this, these waveforms look like v of t equal to v max sine omega t plus or minus theta. Okay, so we know that omega is 377 in this case, which is 2 pi f. If you find f must be 377 over 2 pi, which is 60 hertz. Okay, so the 50 and 100 are the maximum values. Now what I'm going to do, this is called a time domain equation. Now I'm going to convert this into phasor domain equation. When I convert this into phasor domain equation, v1 equal to 50 at an angle of minus 60 degrees. So this 50 came from here and 60 degrees came from there. Okay, so v1 of t, it has magnitude and phase angle. This is called magnitude, and this is called phase angle. Okay, so the format from the previous video, if you remember this is called phasor format. Okay, now same way I can write down v2. See, once I write it in phasor format, it's time independent quantity. Okay, I'm using the capital letters. The previous ones are time dependent quantities. I'm converting a time dependent quantity into time independent quantity, or time domain to frequency domain. This is called frequency domain. Okay, v2 equal to 100 at an angle of minus 30. Now basically I have two vectors. I'm adding those two vectors. Okay, so to add these two vectors, we need to convert this polar form into this in polar form, also called phasor form. Okay, or polar form. Okay, now we need to convert this polar form into rectangular form. So converting, as I mentioned, you need to understand how to do it by using your calculator. Okay, practice it as many times as possible. So I'm going to write it one more time here, how to convert 50 at an angle of minus 60. That's a phasor format. 50 times cos minus 60 plus j 50 times sine minus 60. Same thing, v2 equal to 100 at an angle of minus 30 equal to 100 cos minus 30 plus j 100 sine minus 30. Okay, so cos negative 60, it's going to be a positive number. You will end up with cos 60 is half, so it is 25 minus j, so sine of minus theta is minus sine theta, so we'll end up with minus term there, minus j 43.3. okay, this is v1. And same way, v2 equal to if we convert 100 at an angle of minus 30, we'll end up with 86.6 plus or minus j 50. Now I'm going to add them. Our goal is v final equal to v1 plus v2. I have 25 minus j 43.3 plus 86.6 minus j 50. So that will, the total is, okay, when we add them, it is 111.6 minus j 93.3. And now I converted this into, this is rectangular format, I'm converting that into polar format. So if you remember, converting this polar format is the magnitude, I got this as square root of 111.6 whole square plus 93.3 whole square, and theta equal to tan inverse of minus 93.3 divided by 111.6. That's how I got the theta. So I converted this into polar format. So now I'm going to write it down in time domain. So v final of t must be equal to 145.46 sine 377t minus 39.89. That is the final answer. If you want to, I mean, if some of you did converting this into cos, I can write it down into cos too. So all I need to do is, if I take this as sine theta, it's 90 minus theta will give you. So to convert this into cos, 145.46 cos 90 minus 377t plus 39.89. I mean, minus will become plus inside, so I will end up with the, and we know that 145.46 cos minus 377t plus 129.89. okay, if I take this as theta, cos of minus theta equal to cos theta, so I'm going to convert this into minus theta. So if I take that as minus theta of 145.46 cos minus 377t minus 129.89, that's minus theta, it will end up with 145.46 cos theta, 377t minus 129.89. okay, that's the final answer. This is in cosine format, this is in sine format. Okay, thank you.